Hi guys, you're welcome. Today we are going to take um, one of the application of integration and something very useful that we normally work with every time, and uh, we actually want to talk about area under a curve. One of the application of integration that is used to find the area under a curve and also helping curve sketching and all that. So most importantly, we're going to look at the trapezoidal rule, or rather called the trapezium rule. So let's take a look at it from the beginning. So uh, area under a curve. So if I have a curve, mind you, if I have a curve this, there are specific points. Let's say right from here down here, that's position of x, a, b. Now, their area bounded by this curve, area of this particular point bounded by this curve. So how can we find it? Picking these 2 points as a reference point. Anyway, you can pick any other points, if not this and this. So suppose we have something like this. How can we find the area of that bounded region from A to B? That is what he's talking about. So if this is point A and this is point B, how can we find the area of the bounded region? Now, something simple. So the area for A to B, or let's say this is the lower limit and this is the upper limit, so we take it B to A, is given by the integral. Anyway, don't forget that this curve is going to have its equation. So meaning the area bounded by this curve is equal to the integral of what? B to A of fx dx. That's all. Just integrating the function with the limit of what? B to A. This is the lower limit and this is the upper limit. Just as simple as that. So let's take it into a question. Just let us apply it and see how we go about it. Though I'm going to solve two, let's say a particular question before we move to, and the question I'm going to solve is going to comprise of, it's going to help us in crop sketching, and at the same time we're going to apply this explanation there. So let's take the question that says, I have a question here that says, take for example, it says find the area bounded by the curve. Look at the curve. The curve is y equals x cubed minus 4x squared plus 3x. This is actually the equation of the curve. So, but I won't need to write all that, Find the area bounded by the curve y equals x squared. Oh, permit me to write a question so we'll be able to see a better look. Find the area bounded by the curve y equals x cubed minus 4x squared plus 3x, and the axis. So that's what the question is talking about. So we should find what the area bounded. But anyway, if you notice something, we are not given the point of which the curve is being bounded. Just like what we have here, we have the point A and point B of which we're going to integrate the function to the limit of those points. But here we are not given the point. So how can we actually find the point and even eventually sketch the curve before we proceed? So let's see how we do that. Solution. Let's see how we go with that. So simple. So firstly, to find the coordinates, to find the value of x, the point. So we can just have let y equals 0 So if y equals to 0, so what will happen? We're going to have x cubed minus 4x squared plus 3x all equals to 0. That's it. So then we take the value of x, we solve out the value of x. So if we factorize all, we have x squared minus 4x plus 3 all equals to 0. Then we can still factorize the quadratic expression. So we have, factorizing this, I have let me use a square bracket. So we have x into brackets, okay? Let's take it this way. The two numbers, we're going to have minus 1 minus 3. So we have x squared minus x minus 3x plus 3 all equals to 0. So there we have x into brackets of what? X into bracket x minus 1. Then I have minus 3 into bracket what? X minus 1 all equals to 0. So from which I have x minus 1, x into bracket x minus 1. Let me still maintain my square bracket. X minus 1, then I have x minus 3 all equals to 0. So means we have x, and we have x minus 1, and we have what? X minus 3 all equals to 0. So meaning x equals 0, x equals 1. This is x equals 0 or x equals 1 or x equals 3. So these are the 3 points bounded by the curve. So how can we actually sketch the curve so we can see what is going on or how it goes? Let's sketch the curve. I have this. So if I am to sketch the curve, this is point 0. So I can take this as 1, 2, okay, 1, 2, and 3. So it shows that the curve passes through 1, through point 1, then to 3, because point 2 is not included. So we're going to talk about the area under this curve, the area bounded by this curve is what we are going to determine from that question. So how can we find the area bounded by this curve as it is in the diagram? So though it doesn't pass through point 2, I think it passes through 0, 1, and 3, just like we have sought out. So we can actually find the area under the curve, bounded by the curve. So how can we find that now? So then the integral is going to be, the integral of this is going to be area from what? From 3 to 0, we have equals to the integral of 3 to 0 of that particular function, that is what? X cubed minus 4x squared plus 3x dx. Then we solve out, then we evaluate the limits, then we get our answer, which is the area under the curve. So let's go. Let's get rid of this. So we have, this is actually the solution. It continues here. So area from 3 to 0 equals the integral of 3 to 0 to 3 anyway. So we have x raised to power 4, x raised to power 3 minus 4x squared plus 3x dx. Once you start integrating, you remove the integral sign. So we have 3, 0, x raised to power 4 all over 4 minus what? 4 over 3x cubed plus 3 over 2x squared. So then we substitute the limits. So we have 3 raised to power 4 all over 4 minus 4 over 3 into bracket 3 raised to power of 3 plus 3 all over 2 into bracket 3 raised to power 2 by the time you substitute 0, everything will be 0. Everything will be 0 here. So then we can go ahead to evaluate that. So I think here 3 raised to the power 4 is 81. So we have 81 all over 4 minus 3 goes here. We have that's 4 times 9. But anyway, we can still make use of it. Let's say 3. So we can find the fraction altogether. So we have okay, 3 goes here. We have 3 squared. So 4 times 9, that is 36. So I have 36 all over 1 plus, what else do I have here? I have 9 times 3, which is 27 all over 2 minus 0. Everything will give 0. So let's continue from here. So easy. We can add all together and get the value of the area. So which is 81. The LCM actually is what? 4. Is 12. Sorry, that is 4. So 4 in 4 is 1. That is 81 minus 1 in 36 is 4. So we have 4 times 36. So 4 times 36. So that gives us 144. All plus 2 in 4, that is 2 times 27, that is 54. So let's add all together and see how it goes. That gives us what? Minus 9 all over 4. So now that we have minus this and we know that area of the curve cannot be negative, so what we are going to do is to take the absolute value of our answer. So we have minus 9 over 4, and that gives us 9 all over 4 cubic square. Cubic meter, sorry, whichever value we wish to use. So that is how to find the area under the curve. So the trapezium rule is a technique used in solving or in finding the area bounded by curves that are not easily found using the previous example. So how do we apply it in when such a question comes? So we are going to be given an interval to work with as our limit for the integral. So then we generate an height, or let's say an ordinate, the interval of the ordinate for the graph. So now let's take, for instance, we have the integral of a to b, b to a of a particular function fx, and don't forget this function is making use of trapezoidal rule, dx, using trapezoidal rule. Let me abbreviate to this. So the rule says that the area from B to A will always equals to h over 2 into bracket y1 plus yn, all plus 2 into bracket. Let me use a square bracket here. So we have y2 plus y3 plus y4 plus yn minus 1. Yn minus 1. This is what the rule is talking about. So let me firstly, to make it legible, so we have this. This is what the rule is talking about, the trapezoidal rule. What do I mean by the y1, y2, y3, y4? By the time we solve one example, those are the intervals of the limit. So let's take a question to explain this. So this is just the formula, and how to apply it, you're going to see it in the question now. So let's apply it in a question that says, let's take this. Evaluate the integral of 0 to 3 of square root of x squared plus 1 using trapezium rule by taking the ordinate at we're given the interval of the ordinates to be 0, half, 1, 1 and a half. We have 2, 2 and a half. We have 3, and that is the last point of the limit. So how do we make use of this in solving this question in finding the area bounded by that curve? So it's very easy. So what we're going to do here is firstly we create a table. In our table, we are going to have the intervals. The intervals represent x. So we have 0, we have 1 over 2, we have 1. Then we have 1 and a half. Then we have 2. We have 2 and a half. Then we have 3. Can you see? So just like what we want to start doing, something reasonable. So from there we have x squared. Can you see that? Then we have x squared plus 1. Then we have square root of x squared plus 1, which is the ordinate y. So whatever we get here will be our ordinates y. So then we proceed. 0. So when it is 0, that's 0 squared will be 0. 0 plus 1 will be 1. Square root of 1. Square root of 1 will still be what? 1. Now we have minus half squared. That's 1 over 4. And 1 over 4 plus 1. So that gives us 1 in 4. 4. 4 times 1 is 4 plus 1. That is 5 over 4. So we have 5 over 4. Sorry. 1 over 4 here. Then we have 5 over 4 here. And square root of it will give us, we have to make use of the calculator. So we get in decimal. So we have 5 over 4. That gives us 1.25. So then by the time we find the square root of 1.25, that gives us 1.118. So we make use of 1. 1 squared is 1. 1 squared plus 1 is 2. So square root of 2. So we find the square root of 2. And that gives us 1.414. So then we go for half. That's, let's say 1, that's 3 over 2. 3 all over 2. That gives 1.5. So let's square that. 1.5 times, let's take 1.5 times 1.5. So that gives us 2.25 plus 1, that will be 3.25. So then we find the square root of 3.25. Square root of 3.25. That gives us 1.803. So then we go to 2. So we have 4. We have 5. The square root of 5 gives what? Square root of 5 gives 2.236. 2.236. So then we go to 2.5, which is 5 over 2. 5 all over 2 gives 2.5 times 2.5. That's squared. So we have 6.25. So plus 1 now gives 7.25. Find the square root of 7.25. So we have 2.693. So then we go for the last one. So this gives 9 and this gives 10. So square root of 10, what does it give? That's 3.162. So then we can evaluate our integrals. We can evaluate our integrals. I mean, we can solve the question now. So how do we make use of it? Using the formula, the area from 0 to 3, all equals h over 2 into brackets y1 plus yn, and yn here ends at what? It ends at 1, 2, 3, 4, 5, 6, 7. So we have y7. This is 1, 2, 3, 4, 5, 6, 7. So we're making use of 7. So then the rest is going to be what? Plus, we're going to have 2 into brackets. So we have the y2 plus y3 plus y4 plus y5 plus y6 plus y7. So we go. Let's solve it out. So note that a equals 0.5, which is half. We have made it the interval, that's the height. So the area from 0 to 3 now becomes, let's take it 5, let's take it 1 over 2. So we have 1 all over 2 divided by, or let's say times 2 all over 1. So and that gives us 1. So let's proceed. y1 becomes 1. So we have 1 plus y7 becomes 3.162. 3.162. So all plus, let's add the rest. y2 is 1.18. As we go, 1.414. Then we have 1.803. So I continue here, plus 2.236 plus 2.693. So then we evaluate all. A from 0 to 3, all equals what? This is 1, so we need not to stress ourselves about that. So what we need to do now is just to evaluate the rest and see. Our final answer will be the area. So we have 1 plus 3.162, so that gives us 4.162. All plus, so let's go. All plus 2.236. All plus 2.693. So that gives us 9.326. So adding all together, we have these all plus 4.162, and that gives us 13.49 in 2 decimal place cubic meter. So this is just a simple way of solving, any other question that comes in form of trapezoidal rule. We just have to simplify the table, then solving out the ordinates, then we get the values of the area, and we solve it out. That's all. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.